Okay. Hello, everyone. I'm Dima. Yeah. Thanks for coming. So I want to talk today about Firework AI, and I'm going to talk about open models and how they also have place next to GPT, which we just heard about from the previous speaker. So I'm kind of curious, like from folks here, like how many people use like GPT, like OpenAI in production? Okay, and how many folks use like open models like Llama or Mixer? Okay, so it's actually pretty balanced. So yeah, I guess my point is that it's gonna stay balanced, or maybe even share of open models over next several years is gonna increase. But first, I wanted to talk a little bit about my background. So a lot like at Fireworks, a lot of our founding team comes from Meta and Google AI. So we've been doing this for pretty much better part of the decade, kind of productionizing open source innovation, etc. Myself specifically, previously I was at Meta for many years as one of the core maintainers of PyTorch. So theme of open source is really close to my heart. I'm kind of driving this deep learning innovation through open source frameworks. So what we do at Fireworks is basically we push the same kind of theme of open source innovation, and we help businesses and help developers to use open weights models, build with them, whether it's some small app or whether it's like actually big production enterprise cases. So first of all, like why do you want to might want to use smaller models or open source models? Like what is the trade-off? Don't get me wrong, like GPT is great, GPT-4 is amazing. I'm sure GPT-5 will be even better, and generally frontier models are really great. And if you are trying to, especially like prototype or build a new capability and see what's possible, you should totally use the frontier models. However, while they provide the best quality for all use cases, they don't necessarily provide the best trade-off in terms of cost and UX when you go to production. Like in short, basically, GPT is great at all the things, but most of the production use cases don't actually need to cover all possible use cases. If you're building your customer support chatbot, probably doesn't need to know all 150 Pokemon names or write you poems or stuff like that. What it means concretely, there are several aspects. Like one is them as latency. Basically, if you're using a really big model, which is good at many things for production use cases, often it hinders real-time processing times. So your user interactions become slow and product adoption might suffer. So OpenAI has been proven, for example, from GPT-4 to GPT-4o speed is kind of better, but still in many cases you can pick up a much smaller open weights model, fine-tuned for your use case, and get multiple X lower latency. Flip side of that is operational costs, right? Even if you're using like GPT-4 and you have like moderately popular application, maybe like 10,000 users per day, you can like easily rack up millions in costs per year. We've seen pretty often. Whereas again, using smaller models and tuning the particular use case, or even just using off-the-shelf models provided by providers such as Fireworks, you can often get multiple X. With GPT-4, like Llama is like 30 times cheaper. For GPT-4 is like 10 times cheaper or something, which really adapts as your application goes from prototyping stage to actually pushing to production and getting real usage. And finally, domain adaptability. That's something which we also see with many customers. Is that again, GPT-4 is amazing on a lot of on all the possible use cases, and you can get pretty far with prompt engineering and kind of trying to customize this. But many use cases are actually pretty narrow, right? Whether it's maybe a specialized chatbot or maybe some structured text extraction, which operate in some domain where there is separate terminology or separate vocabulary, where like tuning to a smaller subset is really useful. And that's really where being able to control the model and walk around and like do some customization is really useful. Again, if you go to Hugging Face, there are probably like by now more than 100K open source LLMs, which people fine-tune for all possible use cases. We also see businesses doing this for many different kind of applications which they see in production. So open source is great. You should all go try to use it. You can go to Hugging Face or Meta website or load Llama or Mixtral or whatever, and use it, but like run it even on your laptop. So what is the challenges actually with using this in production? Turns out is like there is still a gap between like just getting the model and building the production application. First, the setup itself is complex, right? You need to go and figure out where to procure GPUs. GPUs tend to break. You need to figure out like what deployment setup, like how to sharp it, how to optimize it for your particular use case. And what we see pretty often, it requires looking into workload characteristics, trying to understand what your application needs are. Like maybe you are building real-time voice assistant and latency is really important for you. Maybe you're building some batch processing and like you really care about throughput, stuff like that. You need to run a lot of experimentation with maybe quality and fine-tuning, etc. And since new models get released almost every week, you kind of have to repeat this process over and over again for different use cases. And finally, when you hit the production, as I said, like GPUs tend to break. Operating actually inference fleet, especially for like specialized accelerators, is not that easy, and that's some of the value which API providers do provide. So even though you want to use open source models and you want to use open weights for quality customization, it still for majority of cases makes sense to use hosted like API providers serving them, taking care of all this infrastructure and tidbits while keeping you in control of quality and outcome for your use case. So that's something Firework has been doing for the past 2 years. And our initial focus was purely on AI inference. So what we've done, given our background in kind of performance optimization, serving production needs at Meta and Google, we can come into this with a lot of experience. So we basically built our own serving stack from the ground up, which all the way from writing CUDA kernels to optimizing kind of deployment and sharding, all of that. So all the kind of tricks which you might imagine for efficient serving and some more which you maybe don't see online, all of that is incorporated. So customizing for different needs. What we specifically focus on is customizing serving needs for your use case. Basically, choosing and tuning hardware and software setup for specific characteristics of the workload and which goals in terms of latency or cost you might have. So what does it mean in practice, right? Different, like especially for LLMs, but pretty much for all generic models, needs can vary very rapidly. Like, I mean, this is like from additional analysis, which is like kind of independent benchmarking organization, like few folks who are running the website. If you haven't seen it, it's pretty cool comparing different providers. Interested in like they have like a selection of workload characteristics, like should they have a shorter prompt, should they have a longer prompt? Changing those workload characteristics, even for like shared public API providers, changes results dramatically. Like for example, a lot of people heard about Grok has been super fast. If you're asking it, hello, how are you? It's gonna generate like 500 tokens per second or something. However, if you like get slightly longer prompt, if you get like prompt of like 1,000 or 10,000 tokens, which often happens with like RAG-based use cases, if you're trying to ground your LLM, performance situation flips quite a bit because hardware characteristics they are running on actually not very favorable for this setup. So like kind of I'm using this as examples that for based on the characteristics of your code, how long your prompt is, and maybe you have different chat sessions for the same user, which kind of have repeated context, etc. There's going to be a really big difference in like how do you optimize software and hardware setup, right? We don't just do LLMs. We also, focus on all different modalities. So, for example, for image generation, Stable Diffusion, with Service DXL is probably the fastest provider. With multiple times faster than what you will get, grabbing your own GPU from one of the GPU providers, for example. We also actually the backend which Stable Diffusion 3 is inserted on from Stability API. And as I said, like there's like even for a public platform, there is a lot of performance you can deploy, but where this tailored performance really comes in is for customized deployments per use cases. And if you, for example, we are trying to productionize an LLM and figure out how much capacity you need to run it, you probably will be looking at a lot of graphs like this, which is basically plots like throughput versus latency, right? So depending on the given the fixed hardware, depending on the load, like requests per second, which my LLM gets, what is the latency of the response? And usually this graph, go somewhere up, and at some point start going kind of more vertical as the server gets overloaded. And you often see, pictures like this where depending on whether you're optimizing for, let's say, latency or throughput, right? Whether you're optimizing for serving as many users under some reasonable constraint or not, you might get very different setups, right? In this case, for example, red line has higher latency if the server is not loaded, but can serve much, much higher loads on the same hardware. So what we often see is that these cases kind of operate on the assumption, I want to serve that many tokens under, let's say, 2 seconds response limit. And that's where a lot of customization might actually end up, and you often see multiple X multiples there. As a concrete example, right? Depending on what's your latency cutoff, right? You can get much better kind of throughput, meaning serving the higher number of users in the same hardware, which means lower cost for you. As a concrete example, I don't know whether you guys know Cursor. It's like a pretty cool kind of AI first code editor, kind of like GitHub Copilot plus, if you will. They're one of our customers. They, for example, they published a blog post how they use us for code rewriting use case, where by post fine-tuning the model and kind of customizing infrastructure setup, they were able to get 12x better performance than out of Xbox One 3, and it's I think 7x higher speed than what you get from they try pretty much every cloud provider doing closed source ones. So it's actually pretty cool blog about where they go into details of how this feature was built, etc. So might be. So that's for tailored performance. Right? In terms of coverage, so we basically support pretty much all popular open weights models, and some of the proprietary ones also through partnerships. So you can go to the platform, try experimenting, productionizing those. And we are pretty quick in adding new ones. For example, Gemma, which was released maybe 2 weeks ago or something like this. What it means in practice is on the platform is that you can go and start with open source models, hundreds of those. We also have some of the fine-tunes which we do ourselves, and I'm going to talk about one of those later on. But also you can go and customize your model. So whether you want to do it yourself on your infrastructure and your hardware, you're welcome to fine-tune, whether it's full fine-tuning or maybe parameter efficient fine-tuning, and upload it to our platform. Or you can use our hosted fine-tuning service if you don't want to figure out how to spin up GPU and start trading. Specifically, if you're fine-tuning parameter efficiently, so if you're customizing these techniques like LoRa, an interesting property of the platform is that we can serve those efficiently kind of on the same GPU shared across many customers. What it means for you is that you can go and train 1,000 LoRa models, upload it to our platform, still call it through API, paying per token without having to pay for hosting that model pretty much nothing in addition. Whereas alternative would be if you were trying to spun up a GPU on your own, you probably need to have a lot of GPU sitting there, not getting much traffic. And we see as many customers kind of using this for either experimentation where they have a lot of variants, or customization per domain, right? For example, if they're themselves a platform and they have 100 customers, they might want to fine-tune for every customer and have a model variant for that, but still serve it efficiently on the same set of hardware without paying crazy cost. So AI, as I said, AI inference is kind of what we started with, but it's as you actually heard from previous talk about GPTs, right? Just LLM is just a building block in a broader kind of AI application framework. There's only that much you can get from just calling an LLM. One of those problems is the hallucination, right? Because models don't know what they don't know. They really try to please. They come up with plausible but maybe incorrect explanations. That's why grounding in RAG is really important. Multimodality and specialization in different modalities is important. And while there's been a lot of progress in native multimodal problems, still chaining different models is pretty common in practice, especially for more robust applications. And as I said, kind of interfacing with external knowledge, whether it's databases or knowledge pieces or documents in kind of RAG setting, is another common pattern for building more production end-to-end AI applications. So the term which a lot of people started kind of using is compound AI, which basically means going from like, oh, just the model is the application, to a broader setup where you might have model in some grounding documents and maybe external APIs and maybe some retrieval system, some tools, etc., etc. So we are like, we started from just real inference, but we're actually building products around this compound AI paradigm. And I want to talk about kind of a little bit about like function calling, and we actually heard about function calling, I guess, in tool use in the previous talk from Kevin. So I wanted to go a little bit under the hood and like how it works and how these like open source models you can customize it further. But yeah, the paradigm which you can imagine why people are excited about function calling is you basically want to have like LLM kind of in a driver's seat, which like interfaces with the customer. Maybe it's customer chatbot or whatever, or like some search application which has access maybe to specialized tuned models. So you have some kind of routing capabilities or different modalities, right? For example, go generate some images or transcribe audio if the user uploads it, etc. But also interface with some product-specific tools and APIs. Go to some actions or go retrieve some data, etc. And kind of function calling as a paradigm is basically sits in the middle for like translating the user request into whatever the action actually needs to be taken. Like as a concrete example, right? If I'm trying to build a hello world chatbot for function calling, which can answer the stock prices, right? You like when the user submits some requests, it's like what's the stock price of Nvidia, which I guess changed since I updated this slide. What actually happens under the hood is that model knows which functions it can call, described as the OpenAPI schema. If I ask for some user request, which might be useful to be answered by this function, and that's what model needs to figure out, it can spit out kind of specially formatted outputs, saying like, hey, I want to call this function. Something on backend is going to go execute this function, give the outputs to the LLM, and LLM kind of goes and says, maybe I need to call more functions, or maybe I want to summarize the result and give it to the user. In the simplest example, yeah, just format that number and say like, hey, the price of Google is that. So that turns out is like there's a lot of models which kind of can do function calling. GPT-4 is really great at that. On open source side, it's actually been a little bit of a struggle with good high quality use cases. Well, maybe Meta will release something in the future. They haven't done so yet. One of the challenges is that, for example, if you take Llama, it's really great in chatting. It's going to be very verbose and helpful and answering. But if you try to kind of curse it to do function calling through prompt, it doesn't actually do very great. There are a lot of fine tunes over there which specialize function calling and train a lot of data just doing function calling, but they lose ability to do chattiness. So, for example, if you ask it like general knowledge question, it's gonna like try to curse it into some function call, even though it's not really not related. And finally, and kind of like balancing between those is pretty hard. And finally, yeah, like GPT-4 is great, or GPT-4o, but often, as I mentioned earlier, kind of lower latency and higher speed are particularly important for function calling models because they are often like a router which sits in front of the kind of more actions. So what we've done, and we also open source this, we've trained a series of function calling models which are Llama fine tunes. But we went to great lengths to kind of balance both chattiness and helpfulness, and make sure that make sure it kind of strikes the right balance there. And while being based on open weights models and paired with our inference engine, it's also very fast. So it's ended up being much cheaper and faster than GPT. So this is like a demo which actually is online and it's open source. So as an example, it has a bunch of function calls available to it, like generate images, draw some charts, ask stock price. So it's kind of labor set for this demo. The model itself is somewhat self-aware. So Sin collapses, and the first question was about, hey, what can you do? So it's like self-aware enough to like say that, hey, this is a functionality which I can do based on which functions are available to me. So for example, we can go and ask it like, hey, can you generate me stock charts of several stock prices? But in this case, instead of asking companies, I'm asking stock prices of top 3 cloud providers. So what actually needs to happen is that model needs to figure out like, oh, top 3 cloud providers like Amazon and Microsoft and Google. So from its internal knowledge, then needs to go and do like 3 function calls because the API we provided to it can only ask for like one single stock price. Then needs to take those results, aggregate it together, call another API for drawing a chart for you, and give you the result, which works. Finally, it's like context aware, right? So if you ask it to, hey, can you add like Oracle to it? It's gonna go use the previous results, append to it, and generate another function. So it really kind of showcases multiple stage workflows, which if you're trying to get multiple function calls working well, it's pretty hard. Just for fun, it has also SDXL hooked up there. So if you ask it for generating some image, it forgets about stock prices because it changes the topic and it just generates your cat in a data center, which of course you wanted to see. So this demo actually is open source, so you can go look how it works under the hood. Basically, if you go to GitHub of Firework FWA, and the model itself is also was open source and posted on our platform. So you can download it from Hugging Face. You can go play with it with high speed on our playground or try building applications with that. Besides just function calling, there are a lot of kind of underlying techniques which I didn't talk about today, kind of useful for structured encoding and fine-tuning, which you can use on our platform to go and customize it further. So like build for your use case, maybe build some model which is good for use case function calling, and that's something which we also kind of help a lot of customers with. And kind of just to wrap up, so I talked a lot about platform, how you can get started. So you can have to like Firework AI to check all the models which are available. Some of them serverless, some of them on demand with per hour pricing. In terms of building model, we provide the whole range, starting from serverless inference, which is basically say OpenAI compatible API, which you're familiar with, very paper token. Don't need to worry about hardware configurations at all, and you can still deploy your fine-tuned LoRa adapters in serverless setting. As you kind of graduate into more serious maybe use case, often people transition to on-demand deployments where we would really help to kind of customize hardware setup for a use case. Like as I talked earlier, you can use still open source models or some customizations which you build on top, and payment is more per GPU second depending on the use case. And finally, for enterprise plans, there is more personalized setup and like even custom feature development, which you can help with that as a use case graduates to more scale and customization. So I mean, we've been around for like around years, but actually we've had a lot of production use cases from companies, ranging from startups to pretty big enterprises, which use it in runtime to serve features in their apps. I talk here about Cursor, but Uber's and Sourcegraph and other Copilot, Presta, etc. So there are more logos being added to the site. So definitely don't be shy to use it. To use it for production, kind of regular SLA and etc. use cases. Also, we're like really care about especially given our PyTorch background, we really care about like developers and supporting like open source ecosystem. We work closely with many agentic libraries or kind of frameworks providers, whether it's LangChain or Llama Index, etc. Actually, on LangChain, based on last year report, we were happy to find that we're actually one of the top open source model providers, which was really great. But it also means that you can start with calling our API, which is OpenAI compatible, so you can often just change one URI somewhere, or you can go use or you can go use the it's one frameworks, whether it's AutoGen or LangChain, Llama Index, etc. Often this one line code change. So that's it for a kind of short overview of the platform. Thank you everyone, and I guess we have maybe time for a few questions if there are any.
Yeah, thanks Dimitro, that was great. One question is, how does DSPy generate candidate prompts? Does it use LLMs at back for this?
Okay, so I mean, I'm not I'm not associated with DS5, but I think I can try to answer this. If I remember correctly, I think they have both like simple DSPy is like this like combinatorial optimization framework, which kind of tunes prompt automatically for you. I think they have both of kind of like you provided a template and it like tries to multiple like patterns of how to do a few short examples and kind of like how to format them and put them together, basically try all of them and see which is the higher quality. And I think they had some LLM-based prompt advising, but I'm not super sure. I suspect it might be a question not for this session, but happy to answer.
Well, we have a few more. So, go ahead.
Thanks for the talk. Did I understand correctly in your custom modeling? That's the fine tuning. So the users will actually upload their data.
So there are two options, right? So again, it's probably similar to like closed API providers do. So we have hosted fine tuning service. So yeah, you would upload your data, or actually you can log some feedback from the platform itself. So if you're calling the open source model for inference, right, and you can give us the signal of is it a good interaction, not a good interaction, we will like log it, use it as data set automatically, or you can upload your data set and then use like a hosted basically fine-tuning service where you like click a button, fine-tune me model on this data set. But you're also welcome to do fine-tuning on your own, meaning that if you have GPUs somewhere or like use some other provider, whatever, you obtained either full fine-tuning or LoRa, you can just upload the resulting model and just serve that. So we see kind of a mix of both.
Got it. So just to make sure, so if we do upload data and you create a custom model out of it, that's not going to be available for anybody else.
No. I mean, you can make it available if you wanted to, but no, by default.
Was there one more question? Yeah.
You have a data for fine tuning. How do you manage the data?
So how do you manage what? So can you...
The data security.
I mean, it's like a regular. We make sure that like data sets don't, you regular like multi-tenant separation, right? So your data sets go like a separate bucket, isolated from other stuff, etc. I mean, what you would expect from like a regular SaaS provider. And so in terms of security compliance, you have like SOC 2 and HIPAA compliant. So all of the kind of regular stuff which you would expect. Again, to reiterate, we're not going to use your data to fine-tune other models or give your data to other people or give models which we tune to other people. I mean, unless you want to make your model public explicitly for everyone to use.
There's no data governance, so you don't provide it. You don't have it.
No, we don't have the feature yet. But I mean, if you mean like actually like managing it now, so it's more like kind of like regular ones. But I'm curious to learn what your use cases are afterwards and maybe talk about it.
We got time for one more question.
I think there is one here.
Oh, there we go.
Yeah, thank you. So let's say I have an app already right now using LangChain, OpenAI, like GPT-4. I have like 20 functions written. I just want to swap in like I think it was FireFunction v2. Like, will it just save me like hundreds of dollars or thousands of dollars if I just swap it right now? Or what's the downfall potential?
I mean, you should try it, right? Because there are big lies and benchmarks, right? So, I mean, from many use cases which we tested, it's actually like if you have a reasonable set of functions, it does pretty good job. So go try it. So I mean, like general API is compatible, so you should be able to just swap in directly. As with any model switches, you might need to do some prompt engineering to it, etc. And maybe if your reasoning is extremely complicated, which usually I don't see in like function calling use cases, maybe model will not be as capable as like GPT-4. But if you're using like GPT-4o, probably it's like 3.5, then that's really matches.
Thank you.